Hey everyone! I wanted to finish breaking down everything about the vector in 3 videos. What I had left was pretty much the adaptive options for order distance and take profit, as well as these border ranges and shot detect. But as I dug deeper, it turned out that everything is not as clear-cut as I imagined. So, to keep it clean, today I will focus on the 2 adaptive options. And I will have to bust out some good old spreadsheets for that. Let's dig in. From last time, we remember that the order distance is, generally speaking, a percentage of the last frame spread, and the starting point is either the upper or the lower boundary of the frame depending on the side. The manual describes the purpose of adaptive order distance as placing orders more aggressively in the direction of the trend. Fine, but what does that actually mean? So, I recreated this exact calculation for the buy side in Excel to clearly grasp what it means and to play around with different values to see how the adaptation reacts. This operates using the absolute price of the coin, which was a bit baffling at first, since everything I've ever done in Moontrader deals with price percentages. In fact, I don't even have an idea what the actual price of anything is, except maybe Bitcoin. Anyway, as the given inputs, we've got the lower boundary prices across 4 frames, 76, 74, 72, and 70, so steadily going down. Also, we have the spread of the last frame, which is 5. Not 5%, mind you, but 5 USDT. And we've got our order distance setting of 5%. Then they do a frame-by-frame calculation of the changes between frames. Okay, got that. Each change is minus 2 USDT. The average change, obviously, is also minus 2 USDT. Now they calculate the order price without the adaptive option. Let's follow that. To the most recent lower boundary price, we add the product of last spread and order distance, and we end up with 70.25 USDT as the order price. Clear so far? Now, the next step is to calculate the price value with adaptation. So, to the order price above, we add the average change across frames. Since that change was negative, the order price goes lower to 68.25. Done, we have a match. That's all fine and dandy, but I don't deal in price points. I want percentages. I want to translate this into a language I can actually understand. So, let's do the relative price changes first. Those minus 2 USDT convert to about minus 2.7% each for each step. So in this example, the lower price boundary is dropping pretty rapidly each frame. Now let's see how big the spread was relative to the lower boundary price. 5 USDT versus 70 comes out at 7.14%. That is pretty big, so supposedly the situation kinda looked like this. Now, I want to know how exactly the adaptation adjusted the order distance. We know that no adaptation uses the 5% setting, and I can reverse engineer that by taking the difference between order price and the latest lower boundary as a percentage of the spread. We do get exactly 5%. Doing the same for adaptation on gives me minus 35%. So, adaptation overrides the order distance and in this case sets it at minus 35%, which is outside the frame. Now it starts making some sense. Adaptation sees that the price has been going down, as evidenced by the negative average change. So, it places the order even lower in expectation of the trend continuing. Fine. But I still want to understand the distance as a percentage of price to make the example truly click. Let's add that. As a percentage of the latest lower boundary, the no adaptation order is 0.36% above. Alright, now we're getting somewhat closer to familiar territory. Let's get real here. The price is dropping nearly 3% every frame, and we are setting the order distance to plus 0.36%. Probably not too smart if the expectation is for the downward trend to continue. Instant wipeout of your stop loss. Do the same for adaptation on, and you get minus 2.5%. Now we're talking, with the price going down minus 2.7% every frame, we set the order distance at minus 2.5 of that price. That's more like it. Alright, let's see what happens in this model if the trend goes up instead of down. Let's go 78, 80, 82. Now that is what I would call aggressive. With the lower boundary going up at a rate of about 2.5% per frame, with adaptation we get the order price even higher at plus 2.74%. Under these circumstances, an order placed just 0.3% above the lower boundary will probably not be filled. So here, the adaptation for the buy side plays a different role. On the downward trend, it attempts to make sure that your position is not immediately wiped out, while on the uptrend, it tries to make sure you have a position at all. Now, with the adaptive take profit, there are even more surprises. Well, first of all, forget the adaptive option for now. The take profit in vector, as I've discovered, works significantly differently from all other algos, even depth shots. The take profit price is determined at exactly the same time as the order price, and their starting reference point is exactly the same, which is the boundary of the last frame. One more time. Unlike all other algorithms, the take profit level is not in reference to the order distance at all. No matter the order distance setting, the take profit price will always be driven only by the take profit spread setting and the last frame boundary. Here, for all these examples of order distance, the take profit level is exactly the same. So, the true distance that the price has to travel from position opening to take profit equals take profit spread distance minus order distance. Therefore, number one, it never makes sense to specify a take profit that is smaller than the order distance. Number two, if you have a negative order distance and a positive take profit spread, it means that the price has to travel back that much farther to get to your take profit. Number three, a negative take profit setting might actually make sense if your order distance is also negative and greater in magnitude. Now to adaptation. I have recreated the example given and discovered that it works exactly like the adaptive order distance. The only difference is that instead of the order distance, the calculation uses the take profit spread distance setting. So, whether you have both adaptations off or both on, the true distance between the order and the take profit will remain exactly the same. They both adapt to exactly the same degree. Thankfully, the stop loss works exactly like everywhere else, and I don't have to make another spreadsheet. Now let's go to a few quick edge cases that came out of this model. Under certain conditions on the uptrend, it is possible for the adaptive order distance to be so aggressive as to push the buy order into the sell side of the order book, opening your position instantly at market. Next, weird things start happening if you have one adaptation on and the other off. For a buy order on a downtrend, if you adapt the take profit but not the order, your take profit price could end up way below the order, and your position will be closed at market as soon as it is opened. Conversely, If on the same downtrend you adapt the order but not the take profit, the distance that the price has to travel back becomes much greater. Therefore, to mitigate this, it would be sensible here to couple this setup with some form of order price down. But on the other hand, if with this setup you manage to catch an uptrend, you're likely to get an instant closure of your position at market. So basically, it is never a good idea to have one adaptation on while the other is off, unless you otherwise qualify the exact shape of the pattern you're looking for. Which brings us to the last point. With adaptation, mathematically, it does not matter whatsoever what happens with the middle frames. In frame 2, the price could drop 99%. In frame 3, it could jump up tens of thousands of percent, but it has no impact on calculations. The only thing that matters is what happened in the last frame relative to the first frame, and how many frame transitions there were in between. This adapts same as this, and same as this. So, in order to actually find clean, more predictable shapes like this, you'd have to use the border ranges. And that I'll cover next time.